Okay, next we're going to speak about the secure network device management. We're going to see what are the unsecure options, what are the secure options, and go configure, of course, the secure options on the iOS and the ASA. We're going to speak about, of course, about in-band management. What in-band means is that the management traffic uses the same, let's say, transit path as the user traffic. Out-of-band management would mean managing the device at the console. So in-band means that, for example, if you would send, it's exactly what the name states, it's in-band management, which means that if server A sends traffic this way, if server A wants to speak with PC A, let's say that traffic is going to be routed this way. Router 2, then to router 3, and then to PC A. While if router 2 wants to manage router 3, it means that traffic is going to flow from router 2. If 2 wants to manage router 3, it means that traffic is going to flow from router 2 to router 3. So as you can see, is the same path which is being used for both data plane traffic and management plane traffic. That's why it's called in-band. Out-of-band management traffic would mean that you manage a device via another method, which means either device is going to have a dedicated management port, which some devices have, or you're going to manage a device via the console. That's out of band. So non-secure device management, it means that the management session is authenticated, but the management traffic is in clear text, which means including the authentication part is going to be sent in clear text. Example is going to be clearly Telnet, HTTP, and CCNP version 2C. So if you want to manage a device via those protocols, all of them are going to enforce some kind of authentication. But the problem is that the authentication credentials are being sent in clear text. Like if I telnet from router 2 to router 3, telnet, 3 is going to ask me for authentication. When I send the authentication credentials to get authenticated, those are being sent in clear text, which means if somebody in the transit path captures those packets, it's going to capture the credentials, which means if he captures the credentials, it means that the attacker can also telnet to router 3 to manage it, which is at least not something that we want in general. Now, secure device management means that management session is authenticated, of course, just like in non-secure, but the management traffic is also encrypted. So for that reason, we're going to replace telnet with SSH, HTTP with HTTPS, and CCNP version 2C with CCNP version 3. So because traffic is encrypted, what that means is that all of those protocols, if I don't want now to manage router 3 from router 2 but via SSH, it means that initially those two devices are going to negotiate a secure communication channel over which all traffic is going to be encrypted back and forward, which means that also the authentication credentials. So once I'm going to SSH to 3, the authentication credentials are going to be sent to this secure tunnel. The authentication credentials. So it means that clearly at this point, if there's an attacker, if somebody in the transit path, in the transit path, captures my SSH packets, because everything is encrypted, it means that he's not going to be able to see my credentials, which means he's not going to be able to use them to also manage that device back and forward. Let's speak about SSH to begin with. So SSH works in 3 phases. So the first phase is that secure tunnel negotiation. The SSH client and the SSH server have to negotiate let's say the secure keys, like the encryption keys and the hashing keys in there. Once the secure tunnel is being negotiated, so we have the keys negotiated in between, then client authentication is being performed. So I get authenticated, and if I get successfully authenticated, then the management plane traffic which I'm going to send over that SSH tunnel is also likewise secured, which means encrypted. Now, secure tunnel negotiation happens based on RSA private public key pairs and Diffie-Hellman exchange. It's going to be a bit similar to the IPsec tunnel being negotiated in there, but it's going to be another kind of negotiation because it has a different scope and it's a different protocol, which is SSH. But in the end, also in this case, the tunnel negotiation happens by using RSA private public key pairs and Diffie-Hellman exchange. And then client authentication is going to be done via username and password. So SSH requires username and password authentication, doesn't support just password authentication. So configuration wise, we have to clearly first generate that RSA private public key pair. And the router domain name, it's in general, let's say, known that in order to generate RSA private public key pair, the router domain name is required, which is not technically correct. First of all, it depends on the iOS code to begin with. But even in the iOS codes which it is required, it's only required if you don't specify a label, which means a name for the RSA private public key pairs. So if you don't specify a name, a label for the RSA private public key pair, the domain name is required because the RSA private public key pair is going to be host name of the router dot domain name. So that's why it's being required to begin with. Now, host name and domain name, if domain name is configured, are going to be used as seed values in order to generate that private public key pair. But it doesn't mean that by knowing the host name and domain name, you can recompute or redo the RSA private public key pair, because those two keys are not derived solely based on the router host name and domain name. So once I generated the RSA private public key pair, then of course we gotta configure credentials, username and password to get authenticated for the authentication to work. And then we have to configure the VTI authentication for username and password authentication, because by default VTI uses password authentication, which SSH cannot work with that kind of authentication. And optionally we can configure other SSH parameters like the SSH version, for example, max number of failed authentications. We can even put in there the specific RSA private public key pair to be used. So a lot of other optional configurations can be performed. Verification wise on the iOS, we verify the RSA key pair if it has been generated. Show crypto key mypub key RSA. We verify SSH server functionality, show IP SSH or show SSH. And I'm going to give you a challenge. What do you think is the difference between show IP SSH and show SSH? So I'm going to split an answer in the Q&A section on here. And verify active sessions, like actively connected users via an SSH session. Show users is going to show you which users are connected on the VTI lines. So let's pick up router 3. We're going to go on router 3 and enable SSH, following those steps. And then we're going to connect from router 2, for example, via SSH to manage router 3. So router 3, if we say show IP SSH, it is disabled because RSA private public key pair is not enabled. Show SSH, it says that no server is running. It's going to be pretty much the same output at this, but it shows up a bit different. Conf-t. So first option is going to be crypto key generate. RSA, general keys, models, let's say, of course, the higher the models, the better, the stronger the security. Let's say 2048. And it says, please define a domain name first. But as I said, if you say a label, give a name to that private public key pair, label SSH pair, it is going to work. Now to verify the RSA key pair, we say show me the cryptographic keys. Show me the cryptographic keys. My public key RSA. So again, the command makes sense. It says show me the cryptographic keys of type RSA. But the command is also my pub key, because on a private public key pair, if you don't configure it otherwise, the private key is non-exportable, which means it's going to be stored by the router in NVRAM in the private config, let's say, file, and it's not readable, because if the private key is leaked, it's going to compromise the whole security of SSH, potentially, not completely, but potentially. So it makes sense again that the command is show me the crypto key RSA my public key, because I only can see the public key, not the private key. Because if I would see it, it means I would copy it and leak it out in there. So as you can see, because I have configured the label, it means that the key name is called SSH pair is the label I've configured. If I have not specified the label, it means that the key name would have been hostname.domain name, and that's why domain name is required in most cases in order to generate an RSA private public key pair. So this is enabled. If you say now show IP SSH, it says that SSH is enabled, not version 1, not version 2, something in between. We're going to enable version 2 ideally. It has now the private public the public key to be used for the key generation with the client. If you say show SSH, it's going to show still that no SSH version 1 server connections running, or V1 or V2. So the next step is going to be to say username SSH user, password SSH password. And the last step is going to be to go under the VTI lines and say line VTI 04, and I want to say login local. So login means use password-based authentication. Login local means use the local database of username and passwords to authenticate any incoming sessions on the VTI lines. Now if you go on router 2, username was SSH user with SSH password. We go over to 2 and we say SSH minus L, the username, which is going to be SSH user on 2 router 3. SSH password. And there we go, I'm connected. If you go on router 3 and you say show users, we see that on this VTI line, a user of SSH is connected from router 2. If you say show SSH, it's going to show you, okay, I have this user connected. So it shows you the active user sessions. And this session has negotiated AES 128-bit for encryption back and forth, and HMAC SHA-1 for integrity of packets back and forth. It's going to be in and out. Ideally speaking, if you want to enable SSH version 2, you should say IP SSH version 2, show IP SSH. It's going to show now it's running version 2. Ideally, you should run version 2 because version 2 has fixed the design security flows, both design flows and security flows of version 1 in there. Okay, this was SSH on the iOS. So user answered, a bit of guess here. Show SSH shows SSH setting parameters. Show IP SSH shows active SSH sessions. It's the other way around as we saw. So show IP SSH shows you the SSH configuration, if it's enabled or not. And show SSH shows you the active sessions in there. Now on the ASA, likewise to generate the RSA private public key pair, we configure the credentials, username and password. We configure SSH authentication for username and password authentication. ASA doesn't have the concept of VTI lines. It has the concept of per protocol type of authentication. So we have to configure SSH for username and password authentication. Then we have to configure the SA from which host can it be managed via SSH. So on the iOS, and this again makes sense, I'm trying to again teach you how to learn and make a reasonable understanding of the differences between different platforms. So on the iOS device, SSH, once you enable it, you don't have to tell the router from which sources to allow SSH sessions, because the router is not a security device. The router, it's a router platform, so it supports some security functions. So it makes sense that if on the router, if you want to restrict from which sources you want to accept SSH sessions, you have to configure the router. While the SA is the other way around. So the router is going to be opened by default. You have to secure it. The ASA is closed by default. You have to open it for specific management sessions from specific sources. Because the ASA, it's a dedicated security device, which makes sense that by default it's closed. So if you want to actually allow management traffic to the SA, you have to tell the SA from which sources do you want the SA to accept SSH sessions. So it's one more step on the SA to configure the allowed list of hosts to manage the SA via SSH. And likewise, optionally configure the SSH parameters, like SSH version, for example, on the ASA as well. Verification-wise, is the same command to verify the RSA, of course, only the public key because the private key is hidden. Verify SSH server functionality, show SSH, and verify active SSH sessions, show SSH sessions. So command-wise, it's a bit different than the iOS. It's another platform, but it makes sense in there. And for example, in general, if you don't know a specific command and you're on the device, as long as you know it should be on our SSH, you're gonna put show IP SSH question mark or show SSH question mark, and it should be somewhere in there. The commands should be self-explanatory. So let's configure the ASA to be managed via SSH from router 2 on this gig01 interface. So we go on the SA, and likewise show crypto key, my pub key. Let's configure the private public key pair actually initially, right? Conf-t, crypto key, generate RSA, general keys, modulus, let's say 2048, label, ASA doesn't put the label keyword, okay. The SA has a default set of RSA, of public-private RSA key pairs. So you can optionally replace it with a stronger set of key pair. So the SA has by default that pre-computed. If you say show crypto key mypub key RSA, this is now the default one, but with a strength of 2048 bit. Conf-t. Then we have username, ASA SSH, password, ASA SSH, let's say. Step number 2. Step number 3, enable AAA authentication, SSH. And this is misleading because the console you may believe that it means console access, which it doesn't. console actually means VTI lines for the SA. So I'm going to say I want to authenticate SSH sessions on the VTI. How? And I will say locally, which means via the local database of usernames and passwords. And finally, if you say show run SSH, SSH is not allowed from any source. So if you want to manage ASH3 on this interface of Gig01 from router 2's Gig01 interface, we have to tell the SA to allow that session, that management session. So we're going to say SSH, I want to allow an SSH incoming session on which interface? SSH from which source? From router 2, 136.1.38.2. Inbound on which interface? On the outside interface. So show SSH is going to show you if it's enabled and the allowed versions, and from which sources is SSH allowed. Of course, we can say SSH version 2. Ideally, you should hardcode this to allow only version 2. So show SSH. Again, now only version 2 is allowed, and only from that source of router 2, and only if the session comes inbound on the outside interface. So we go to router 2, and we say SSH minus LASA SSH the user on 136.1.38.1 ASA SSH, and we're connected to ASH3. If you go to ASH3 and you say show SSH sessions, it shows you that likewise router 2 is connected with this username ASA SSH, and likewise inbound, outbound, the negotiated encryption algorithms for that session and hashing algorithm for that session. Okay, I see a couple of questions here. Piyush says only username and password are encrypted in SSH, or complete data is encrypted. So Piyush, as I stated before, initially what happens, so everything is encrypted in the SSH session, both the authentication credentials of the client and also whatever traffic you send over that SSH session to configure the router. So how this works is very simple at a fundamental level. Is that if router 3 is the SSH server and 2 is the SSH client, initially we have some clear text traffic back and forth being sent. But when router 3 replies to router 2, is gonna send to router 2 its public key. So 3 sends to router 2 its public key. So far this traffic was in clear text. Then what happens, router 2 to the Diffie-Hellman exchange, and in those protocol, in those two packets, they negotiate the cipher algorithms, and router 3 sends its public key to router 2. Then what router 2 does is that it's gonna send to router 3 its Diffie-Hellman public key. But this is gonna be encrypted with router 3's public key, which means only router 3 can decrypt that message with its private key, which is the pair of that public key. So now the Diffie-Hellman exchange is performed, and then to the Diffie-Hellman exchange they end up with the keys to perform encryption and integrity. And now at this point, both 2 and 3 have ended up with the secure keys to secure all traffic back and forward. So next what's going to happen, now the secure channel has been built successfully. We have negotiated securely without sending the keys over the wire. We have negotiated the keys to use to encrypt the traffic and provide hashing. And then, so the secure channel is being established. This channel means it's going to be encrypted via negotiated encryption algorithm and authenticated via negotiated hashing algorithm. So now in that channel, the authentication happens to begin with. 2 gets authenticated, sends its credentials, gets authenticated. If authentication is successful, then likewise through that secure channel, all traffic is being sent to router 3. So whatever you configure to router 3 is going to be likewise sent in that secure channel. So nobody in the transit path can actually, if they capture the packets, they cannot see. They're going to see scrambled packets, ciphertext packets, not clear text packets. So Piyush, I hope I answered the question. A question from Matthew: if we enable V2, is V1 still active, or do we need to turn off SSH V1? So you cannot run multiple versions at the same time. So you can either run version 1 or version 2 on the iOS code. On the ASA, by default, both of them are allowed. So on the ASA, to keep it simple, if you go on the ASA and the iOS and you say IPSSH version 2 on the iOS or SSH version 2 on the SA, then at that point only version 2 SSH traffic is allowed. But by default, iOS allows version 199 and ASA allows both V1 and V2. User says, why is it showing version 199? I have no idea, to be honest with that. It's not version 1, it's not version 2. Probably that's the way to show that it supports both of them. I'm not sure why it shows up version 199 by default. A question from Hamdi: what modulus means? So that is the size, which means the strength of the RSA key pair. So Hamdi, please take. I recommend you to take a look on the CCNA security class, not the bootcamp class, but the advanced technologies class, where we explain there in details the diffie-Hellman exchange, the RSA, the private-public key cryptography, and of course the strength in there. But to give you a simple answer, the higher the number, it means means the key is gonna be longer, which means it's gonna provide better security. User said, yeah, I've heard 199 is backward compatibility thing to show that it supports both versions. I know that as well, that yes, by default also iOS supports both of them, but I'm not sure that, you know, it shows up at version 199 just to confirm it supports both of them. It is what it is. I was not able to. I looked at over Cisco's documentation to also try to identify why it shows up version 199 and not version 1 or version 2. I was not able to find like a strong, let's say, correct, valid statement of why that is. So I don't know how to answer. But yes, it could be because it supports both versions. So that's the way of Cisco has to show up that it supports both versions by default.